So, hello everyone, my name is Jesver and I'll be covering the sensor setup and data collection aspects of our IoT system. And my main responsibilities included setting up the temperature and touch sensors and integrating them with our microcontroller. These sensors are crucial to our aspect and project because they allow us to monitor environmental change in real time, which can be especially valuable in smart buildings, industrial facilities, and environmental monitoring. Our goal was to create a system that can collect accurate data and transmit it efficiently, allowing users to make informed decisions based on real-time insights. So our project is the way on the monitor environmental conditions. So the working principle of the temperature and the touch sensor, let's dive into how this sensor gonna work. Starting with the temperature sensor, as you can see, we use a thermistor we use this thermistor and then which changes its resistor based on the temperature it sends. By reading these resistor values, the microcontroller can calculate the temperature in real time. This is particularly useful for monitoring temperature sensitive environments where even small fluctuation can be significant. On the other hand, the touch sensor is designed to detect physical contact or proximity. This sensor is especially useful in applications where physical interactions need to be monitored, such as access control and restricted areas. The touch sensor sensitivity allows it to detect even light contact, making it versatile for various security applications. So in we also we also maintain this carefully with the given port number using the lab manual, and this is quite effective and workings. And right now I'm gonna talk about the code implementation and the data processing. In this, we programming use the ESP32 microcontroller using Arduino to read the values from both sensors and send the data to the cloud. Here is the brief look at the code. Let's see on the code. Okay, so in the first part, we're talking about the for the first two six part, we include the Arduino, we include the Wi-Fi, the PubSub client, the Arduino JSON, the InfluxDB client, and the InfluxDB cloud. So what's the codes used for? These libraries are essential for the project, which provide for the Arduino.h is provide basic functions for the Arduino platform, and then for the Wi-Fi.h it means Wi-Fi the connection, and the PubSub client is used for the MQTT, which we will use to publish the sensor data. And the Arduino JSON is to manage the JSON data, which is helpful for the structured data. However, for the InfluxDB client and the cloud, it allows us to send the data to the InfluxDB database. For the Wi-Fi credentials, we're using our own phones, which taking a hotspot, and we're using the char because it defines the SSID, the network name and password for the Wi-Fi network. This allows the ESP32 to connect to the specified Wi-Fi network. And the InfluxDB setup for the, as you can see as the reason, we're using the InfluxDB URL token, ORG bucket, precision, and the other one, as you can see, right, precision, the max batch size, the wide buffer size. This is for the parameters to connect to InfluxDB. This defines the URL token, organization ID, where the sensor data will be stored. So what the wide precision for? It specifies the precision of the timestamps, and the max batch size and the wide buffer size is to control the data batching for an efficient uploads. And afterwards, the time zone info, the time zone info. In this case, is used for the sets the time zone information, which is important for accurate timestamps in InfluxDB. Afterwards, we create the InfluxDB client. The InfluxDB client is used for allowing the ESP32 to interact with the database using the provided parameters. And afterwards, we go to the MQTT configuration. Okay. So in this MQTT configuration, MQTT broker is used to set the address of the MQTT broker, and then afterwards for the topic is to publish or subscribe for the data transfer, And the username and the password is a credentials for the broker. And the port number, as you can see, 1883 is a port number for the MQTT communication. And the topic subscription is for list the topics for the MQTT that the ESP32 will subscribe to. This allows it to receive the control commands if needed. And the sensor pin definition. Sensor pin definitions, in this we define the touch sensor pin on number 14 and define the thermistor pin on number 1. This is to specify the GPIO pins connected to the touch sensor and the temperature sensor. We will read data from these pins in our code. The global variables, volatile integer, voltage scan time to TA clock calibration. So IND channel 2 scan is used for Wi-Fi channel scanning. The THR is the threshold for Wi-Fi RSSI, receive signal strength indicator. And the scan time is used the interval for scanning time in milliseconds. And afterwards, there's a TA clock calibration, which tracks time for clock calibration. We also use the string for the client ID, Wi-Fi client, ESP client, and pub sub client. So this is for to set up MQTT and Wi-Fi client instances for handling network connections and data transfer. And afterwards, there is a function declarations. As you can see, we call the callback MQTT reconnect fun subscribe and fun connect to Wi-Fi. So what this for? So this is to declare functions used for MQTT Wi-Fi and sensor data handling. And afterward, there's a temperature reading function. In this case, as you can see, the temperature reading functions to calculate the function needs data from the thermistor, converts the analog value to the temperature in Celsius and returns it. The conversion formula accounts for the thermistor resistance and calibration values. And the void setup, as you can see in the void setup, which include MQTT, and every of this code is used for attempts to connect to the MQTT broker. If it is failed, it retries every 2 seconds. And on the next slide, on the line 98 to line 119, this is for to check the InfluxDB connection and prints the connection status and the loop function. As you can see in the loop function, sorry. So what's for the loop function? So this is for the loop function is to reconnects the Wi-Fi if it is disconnected. And afterwards, there's a serial pin, the void callback MQTT. The void callback MQTT is for reconnects to Wi-Fi. Is to reconnects to MQTT if disconnected and processing incoming messages. And this is the sensor. Afterwards, there's a sensor data collections from the JSON document, the void callback MQTT, and this is for creates a data point for InfluxDB as well, and including the tag and fits for touch and temperature data. And let's jump to the other part. If you can see the void reconnect, the void fun subscribe, and the void fun connect to Wi-Fi. And every of this is to publish the sensor data to the specific MQTT topics for external access. So this briefly explain the work of this code. So this is once we have the sensor data, we can use the MQTT protocol to send it to our cloud storage. MQTT is an efficient way to transmit data with minimal delay, which is important for real-time applications like ours. So the challenges in data handling. One challenge we faced was calibrating the sensor for accuracy. This involved fine-tuning the code and testing in different conditions to ensure the readings were reliable. Another aspect we focused on was error handling, where we implemented checks to retain data transmission if the network connection was lost. So that's it for my part, and the next part gonna be taught by my peers, Raymond, and he's gonna talk about the influx, the Grafana, and the MQTT as well. Thank you.